I'll start the class at 4:35. I'll wait for 3 minutes. Okay, so it's been 5 minutes. I've started the live. So I'll begin the class. Okay, now in your list of homeworks, I had found that one student had asked me that, sir, what is ferroferric oxide? I'll begin with this today. What is ferroferric oxide? Because if I say ferrous oxide and if I say ferric oxide, fine. Suppose I am saying ferrous oxide, that does mean that I am using the iron has two valencies, Fe plus 2 and Fe plus 3. So if you are using Fe plus 2, it is known as ferrous or iron 1, whatever. It can also be known as, iron 2, not iron 1. Iron 2 oxide, because the 2 valency is used. And ferric oxide is also known as iron 3 oxide. Iron 3 oxide. So ferrous oxide is definitely Fe plus 2 and O minus 2, which gives us FeO. Fine. And ferric oxide is definitely Fe plus 3 and O minus 2, which will give me Fe2O3. So that means the ferrous oxide and the ferric oxide together will form ferroferric oxide. Means this is a special thing that you should understand, that FeO plus Fe2O3 if you do, then you will get Fe3O4. Fe plus Fe2 is Fe3, O plus O3 is Fe3. They get conjugated with each other, tie up with each other. So this comes from both ferrous and ferric oxide. Okay, so that's why it is known as ferroferric oxide. So that's why it is known as ferroferric oxide. Now, this is one thing that you should understand, that's why it is known as the ferroferric oxide. So that's it. One compound was there, ferroferric oxide. So one student had asked me one doubt, so I solved this doubt. So that is ferroferric oxide. It is also known as iron 2, 3 oxide. It can also be said like this because it is iron 2 oxide, it is iron 3 oxide. So beginning from oxides only, today I will start this class with the discussion of the oxides. You see, any metal or non-metal, okay. So what are the examples of metals? Example of metal is sodium, magnesium, aluminum, potassium, calcium, gold, silver, zinc, iron, copper, barium. Okay, so these are the examples of metals that we come across. Lithium. Okay, and the examples of non-metal which we come across are hydrogen, written as H2, helium. Oh, sorry, no, helium is a noble gas. Nitrogen existing as N2. Then oxygen existing as O2. Now this is the special element here. This is the special element here, oxygen. Okay, existing as O2. Oxygen's charge is O minus 2, as you know, as you have learned. Okay, so that is one thing. Now then there are other non-metals also, like fluorine existing as F2, then sulfur as S8, phosphorus as P4. Okay, so all these non-metals are there. Bromine as Br2, existing as Br2, iodine existing as I2. So all these things were there. So you see, these all things are there that we have understood. And remember that any metal, like I was saying, any metal or non-metal, fine, any metal or non-metal, okay, maximally they combine with oxygen, either very slowly or very fast, they do combine with oxygen. Remember, any metal or non-metal do combine with oxygen. Okay, they do combine with oxygen. Any metal or non-metal, they do combine with oxygen. Okay, and form its oxide. Okay, suppose for example, if in case of metal, Na combines with oxygen to form Na2O, K combines to form K2O. Okay, then Mg combines to form MgO, means all the metals combine with oxygen to form its oxide, all the metals whatsoever, either very slowly or very fast or very vigorously or taking years after years, months after month. It depends on how more reactive the metal is. All those questions will be aroused later on. However, as we go on understanding chemistry throughout class 10, okay, we will understand those concepts slowly. But here I just want to say that oxides means oxide of any metal or non-metal. Suppose for example, zinc also has its oxide, zinc ZnO, and the writing down the formula of the oxide is very easy. Then there is carbon dioxide, there is sulfur dioxide, there is sulfur trioxide, and in these cases no valency exchange is not the matter. Just listen to the name carefully, carbon dioxide, sulfur dioxide, sulfur trioxide, just that is simple. Okay, then nitrogen pentaoxide N2O5, nitrogen dioxide NO2. Okay, all these things are there. Nitrogen monoxide NO. Okay, so lots of nitrogen and निजेरी I mean nitrogen का खुद का ही बहुत सारा oxides है. And then P2O5 is there, phosphorus oxide. So all the non-metals do form oxide. However, oxide of iodine, bromine, fluorine, oxide of iodine, bromine, fluorine, these all oxides are very rare to see because there are reasons. iodine oxide, bromine oxide, fluorine oxide, chlorine oxide. These chlorine, bromine, fluorine, iodine, these 4 elements, they are called halogen elements. Why they are called halogen elements? Because they are found in the sea. Okay, and oxygen combining with them is very tough, okay, because they themselves are very electronegative. But however, you will come to understand that why they do not combine with oxygen and form their oxides, and rarely they do it. All those things are in higher classes, but I need you to remember, or I need you to understand that these, except for these 4 non-metals, the normal non-metals do form their oxides. The metals also do form their oxide. Look, oxygen is abundant in the atmosphere. Okay, in the atmosphere oxygen is abundant. Okay, and oxygen is roaming around as O2, fine. But when it comes in contact with any metal or non-metal, okay, it does form its oxide. I will give you one simple example. Suppose, for example, iron rod, okay, iron is an metal, is kept for days and days. After some day you will find that there is rust in the iron. Okay, there is rust in the iron. So what about that rust? That is actually iron oxide, Fe2O3. Okay, so you see what has happened is oxygen in the atmosphere has reacted or combined with the metal. So that happens with all of them, most of them. Okay, either very fast or very slow. In the same way, I will tell you one thing, that sodium and potassium, these two are stored in kerosene. Stored in kerosene. You know why they are stored in kerosene? They are stored in kerosene because they react with oxygen. If they keep in atmosphere का oxygen के साथ, they will react vigorously and very fast and produce heat and light, and it will be like a bombing experience. Okay, so reaction in this case is very fast, reaction in this case usually is very slow. Okay, so these all things are there, as because oxygen is in the atmosphere, so it slowly or fastly it combines with all the metals and all the non-metals, okay, and forms its oxide. So oxide is a special thing that you should understand, the concept of oxides. Okay, so I hope that you have understood. So that is one thing. Now little bit we will understand about chemical bonding. Chemical bonding. Now you will say that, sir, yesterday so you told about chemical bonding. We have seen in the video. Today I will make you understand that how chemical bonding occurs. It is very important to understand at this stage that how chemical bonding occurs and what are the types of chemical bond and whatsoever. Little bit hint I had given yesterday that chemical bond or chemical bonding is the force which holds the molecules together, is the force which holds the molecules together. Chemical bonding is the force which holds the molecules together. So I hope that you understand that there are covalent bonds, and these are types of chemical bonds. There are electrovalent bonds, and there are coordinate bonds. Now these are the types of chemical bonds or types of forces between the molecules. Okay, there can be huge lot of molecules in front of you. Today while doing the homework also, seeing the previous video, you must have gone through huge number of molecules, must have understood a huge number of molecules. Okay, so there should be a huge number of molecules. Okay, but you see in those molecules, for example, O2 is a molecule, N2 is a molecule, NaCl is a molecule, okay, SO3 is a molecule, SO2 is a molecule, CO2 is a molecule. Either it is a molecule of a compound, MgO is a molecule, MgCl2 is a molecule, Al2O3 is a molecule, Fe3O4 ferroferric oxide is a molecule. So in these molecules Okay, there is force of attraction between the constituent atoms of the molecules, the 2Al and the 3O present here, the 3Fe and the 4O present here. There is force of attraction between the atoms, and due to this force of attraction, they are bound to each other, they are combined with each other. Okay, so that is one thing. You have to understand that what is this force or binding force known as? It is known as the chemical bond. It is known as the chemical bond. Now, as because it is known as the chemical bond, I hope that you understand that it is known as the chemical bond. Now, what happens is that you have to understand a little bit more that what are the types of chemical bonds and how do they form? Now, types, so you know that there are 3 types, and how do they form? Now, when we understand how do they form, on the basis of that, first of all we will study the electrovalent bond, then you will understand, okay, that on what basis I have divided into 3 types. Number 1 is electrovalent bond. Now, first things first, that electrovalent bond is a type of bonding in which you see what happens is that the molecules combine with each other, okay, of a metal plus of non-metal, of a metal, of metal and non-metal. Atom of a metal, an atom of non-metal, when they combine, they do so by electrovalent bond. Now, such type of compounds when they form are known as electrovalent compounds. I will give you an example. With the example you can understand very well. Suppose for example sodium is there. You know that sodium is a metal, and as because sodium is a metal, sodium will have the tendency to lose electron. Okay. So, sodium will have the tendency to lose electron. Now, you already know that it is a metal and it will have the tendency to lose electron. So, now those who are thinking that this is very difficult to understand, how sir told that sodium is a metal, you have to go through my all the previous videos to understand that how sodium is a metal, see them, write them on and on. Okay, then only you will be able to understand this video properly. So, this is why I was emphasizing my previous video so much. Okay, so now what happens is that sodium is a metal. Now, as because sodium is a metal, 281 is its electronic configuration, like you have done the previous homework, and it loses 1 electron to become Na plus. So, if I see it in structural way, this is the sodium atom, okay. So, there are protons and neutrons inside the nucleus. I am not concerned about the protons and neutrons inside the nucleus right now, because chemical bonding occurs between the electrons only. So, first 2 electrons in the first shell, in the second shell there are 8 electrons. Okay, and in the third shell there are 1 electrons. So, to make it stable, it will lose 1 electron. It will lose 1 electron. We are very accustomed of this fact. Again, I will show you another element, that is suppose chlorine. Okay. Now, chlorine is, if you count, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. It comes in 17. So, 17 means 287. Now, it is clear that it will gain 1 electron. So, it will gain 1 electron to become Cl minus. So, it will become 288. Now, if I see structure wise, the neutrons and protons will be in the nucleus. I am not concerned about it much. Now, this is 2. 1, 2, 3, 4, 5, 6, 7, 8, and in the last shell also 1, 2, 3, 4, 5, 6, 7. Now, it will take one electron, right? It will take one electron. Now, how about the idea? Just think that it gives one electron and it takes one electron. It must be occurring in your mind. Sir, how about that the sodium ka electron which it gives is taken by chlorine and both become satisfied? Definitely that occurs. The electron given by the sodium is taken up by the chlorine, and what happens is that when sodium gives the electron, definitely it becomes Na plus, and when chlorine takes the electron, definitely it becomes Cl minus. You can see, have a look, you know this, and they come in close proximity, very close to each other, and there is high force of attraction between the positively charged cation and the negatively charged anion. There is very high force of attraction and they bind with each other and thus forms NaCl. And thus forms NaCl. This type of bonding is known as electrovalent bonding. So, I hope that you have understood that in electrovalent bonding, what will happen is, first step is one element A, which is the metal, will give the electron, and another element B, which is a non-metal, will definitely take the electron. Okay, so that's the arrow I. It will give and it will take the electron. When a metal gives the electron, it becomes positively charged, so it will become A plus or maybe A plus 2. I don't care about it. Okay, but again the B will become B minus or B minus 2 or B minus 3. How many electrons given taken, I will come into that matter later on. But what is happening? One of the metal is giving electron, the non-metal is taking electron, and as because giving electron forms positive charge and taking electrons form negative charge, cation and anion has high force of attraction, and as because one is giving and the other is taking, definitely they are in very close proximity to each other. And as because they are in close proximity, very close to each other, so that means there will be high force of attraction between them and they will form a compound. So, such type of compounds or such type of bonding will have a metal and a non-metal. So, that is electrovalent bonding, and such type of compounds are known as electrovalent compound. It is given another name also, ionic compound. And it is given another name also, ionic bonding. Now, you have to understand that why ionic, because it involves the formation of ions. One loses electron, one gains electron. We very well understand that in electrovalent bonding what happens? In electrovalent bonding, a metal and a non-metal is involved. Who is involved? A metal and non-metal is involved. One gives the electron, the other takes the electron. So, this is what happens, in case of electrovalent bonding. So, this is what happens in case of electrovalent bonding. I hope that you have understood this as a matter of fact, and I will then shift to another example. Suppose now, if anyone, it is very easy to understand that if anyone tells us from the set of compounds, I will give you another example, then I will speak a little bit more about it. Let me give you example of MgO. Okay, let me give me example of MgO. Now, in case of MgO, what is happening is that Mg is a metal. You know magnesium is a metal and magnesium is plus 2. I will not go into the details now because you already know how it forms plus 2. And oxygen is minus 2, and you already know they exchange the valency. I am not talking about exchanging valency here. But how about that magnesium losing its 2 electron, magnesium is becoming magnesium plus 2 from magnesium because it loses 2 electron, right? And chlorine is becoming O minus because oxygen is gaining 2 electrons. So, how about this 2 electron lost or given out is going to oxygen because it is taking those electrons, and they come in close proximity to each other, and Mg+2 and O-2 has a huge force of attraction between them, and they will form MgO. It is possible. So that is what is an electrovalent compound, or this type of bonding is electrovalent bonding. From a set of compounds given to you, or from a set of compounds, if I write down the certain names, suppose for example I write down randomly certain names: CO2, SO2, H2O, NH3, MgO, CaO, Al2O3, AlCl3, PH3, KCl, AlN, AgBr, AgCl, CH4, LiCl, C2H6, then okay, Mg3P2, I hope that pretty much examples have given. Now picking out, okay, picking out the, what we can say, the electrovalent compound from here is very easy. Picking out electrovalent compound from here is very easy. It is not at all difficult to pick out electrovalent compound from here. So why is it not difficult to pick out electrovalent compound from here? If you have good knowledge of who are metals and who are non-metals, if you are already accustomed with the previous videos, then you can easily pick out that in an electrovalent compound always there will be one metal and one non-metal. So definitely in carbon dioxide, carbon and oxygen both are non-metals, hydrogen and oxygen both are non-metals, magnesium and oxygen, one is metal, one is non-metal, aluminium is metal, oxygen is non-metal, SO2 metal, sorry, non-metal, nitrogen non-metal, hydrogen non-metal, calcium metal, oxygen non-metal. So this is an electrovalent compound. Aluminium non-metal, aluminium metal, chlorine non-metal, electrovalent compound. Phosphorus non-metal, hydrogen non-metal. Potassium metal, chlorine non-metal. Aluminium Al, aluminium metal, nitrogen non-metal. Silver metal, Ag plus, Br minus, non-metal. Ag plus, Cl minus, non-metal, metal, non-metal. And then this is the metal, non-metal, carbon non-metal, hydrogen also non-metal. LiCl, Li is a metal, Cl is a non-metal. C2H6 is non-metal. Mg, magnesium is a metal, phosphorus, okay, is a non-metal. So definitely this is an electrovalent compound, this is electrovalent, this is electrovalent or ionic compounds, all the red marks. So how? Without doing the bonding I am being able to find out, because one carries the metal, one carries the non-metal, and whenever in a compound there is a metal and a non-metal, definitely it has formed by, well, the metal must have given the electrons. Likewise I have said, I have discussed in this portion, and the non-metal must have taken electron, and that's why one takes the electron, one gives the electron, and what happens is that there is formation of the bond or the electrovalent bond, in this way like I have discussed, and they are electrovalent compounds. So to find out electrovalent compounds, it is very easy that one will be metal, one will be non-metal. So the bonding between a metal and a non-metal means if the element is a metal and if the element is a non-metal and they form a compound, it is definitely formed by giving and taking of electrons, that is involvement of cation and anion and high force of attraction between cation and anion. Such type of compounds are known as ionic compounds. Such type of compounds are known as ionic compounds. So I hope that you understand this concept very well. Such type of compounds are known as ionic compounds. So that is how we proceed now. Okay, so that is one part. I hope that you have understood this part. Now, what is covalent compound or covalent bonding? But before going into covalent compound or covalent bonding, okay, let us understand covalent compound or covalent bonding first. Covalent compound or covalent bonding. Okay, I'll just give me a 1 minute or 1.5 minute or 2 minutes ka break, and then I'll come back. I'll just be back. I'll not, this video will be going on, okay? Don't go out of this video if you are seeing. Okay, so I'm back. I will again proceed with covalent bonding or covalent compound. It is formed between non-metals and non-metals. Okay, it is formed between non-metals and non-metals. Now, see, if I take a non-metal, suppose for example, I take the example of CH4. It is known as methane. Okay, it is known as methane. CH4 is known as methane. Now, when I take the example of CH4, I see that it is also a non-metal. It is also a non-metal. So, when I say that it is a bonding between non-metal and non-metal, it is very easy to understand that this CO2 is a covalent compound, H2O is a covalent compound, NH3 is a covalent compound, CH3 is a covalent compound, SO2 is a covalent compound, CH4 is a covalent compound, C2H6 is a covalent compound. These all are covalent compounds. Okay. Now, as we have seen that this is a non-metal, this is also a non-metal. Now, you know that both the non-metals, okay, loses electron, however gains electron. Non-metals gain electron. Now the concept is non-metals gain electron. Suppose for example I take CO2, both of them gain electron, and actually you have learned previously also that carbon and silicon share their electron. They share. That's why and I have put them into non-metal category only. Now, I just want to say that if it is a bonding between a non-metal and a non-metal, both of them are electron gainers, not electron losers. So, it will not be a bonding between a charged and a charged particle. Okay. No one is losing and gaining. One metal has to be present to lose the electron. It is not present. So, there will be actually not giving or taking of electron. It will be sharing of electron. It will be sharing of electron. Definitely it will be a sharing of electron. Electron will be shared, as I have written here. Electron will be definitely shared. Okay. Configuration. Why is the sodium losing the electron to become 2H? Why is the chlorine taking the electron to become 2H8 from 2H7? So that is their aim is to fulfill stability. Okay, to attain inert gas electronic configuration or electronic configuration like noble gases, like you have understood in the previous video. This is the reason why they lose or gain electron. This is the reason behind losing and gaining electron is that they try to attain the stability. Okay. So, attaining stability is the basic reason to do the bonding. Remember that I guess now I hope that you can hear properly. Okay, so we are understanding about covalent compound or covalent bonding. Okay. And we are understanding about the sharing of electron. In case of covalent compound or covalent bonding, how the bonding occurs? The bonding occurs by sharing of electrons. Okay, and as the bonding occurs by sharing of electrons, That's why it is known as covalent compound or covalent bonding, and it occurs between non-metal and a non-metal. It definitely occurs between a non-metal and a non-metal. So this is a compound which is covalent bonding. This is a compound which is a covalent compound, covalent compound, because you see non-metal, 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 non-metal. So definitely they are covalent compounds. This is a covalent compound, this is a covalent compound. So definitely they are covalent compounds. So in case of covalent compound, what do we see? In case of covalent compound, we see, in case of covalent bonding, we see that there is generally sharing of electron. Okay, the electrons are being shared. No one is there to give the electron or take the electron, and electron is being shared. This, listen to me very carefully. Either giving of electron to become an anion, or taking an electron to become a cation, and anion and cation, metal and non-metal together forming electrovalent bond, or sharing of electron. All these things are done by elements. Why? All these things are done by elements to attain stability. Like I said, to attain stability, to attain inert gas electronic configuration. Losing electron makes it 2-8. Gaining electron here makes it 2-8-8. So it is to attain stability or to attain inert gas electronic configuration. So that is why they do it. So for the same reason, they will share electron. For the same reason, to attain inert gas electronic configuration, they will share electron, but there will be no one to give the electron or to take the electron. There will be sharing of electron. Suppose, for example, I'll give you a very, funny example. Suppose, for example, there is a boy. This is Shobhargo. And there is a girl. Okay, this is who? Let this be Irina. Okay. Okay. Now, suppose I gave Shobhargo 3 chocolates. How many chocolates I gave? 3 chocolates. And I gave Irina 3 chocolates. Okay. I told Shobhargo take 3 chocolates. I told Irina that take 3 chocolates. And then I told them that both of you should eat 4 chocolates. Now they are at a fix. That sir has given me 3 chocolate. Sir has given me 3 chocolate. Now, how can we each have 4 chocolates? We cannot. However, now the concept is that how will they share the chocolates? Now, let me tell you, this is little bit filthy though. What will happen is, suppose they decide, suppose Shobhargo has 3 chocolates. This is Shobhargo's chocolates. Let me write it S3. And this is Irina's chocolates. Let me write it A3. Suppose Shobhargo decided that I will take 2 chocolates. Irina decided I will take 2 chocolates. The 2 chocolates they have taken. Okay. Now they are left with 1 chocolate. And Irina is left with 1 chocolate. One chocolate is left with Shobhargo and Irina. So already 2 chocolates and 2 chocolates eaten. Half done. So more 2 chocolates. He will also have to eat 2 chocolate. He will also have to eat 2 chocolate to make it 4 chocolate. But how many they have? He has in hand 1 chocolate. He has in hand 1 chocolate. So if they eat up 1 chocolate, it will be 3. That is not done. I want 4. So what they do? Shobhargo and Irina keep the chocolate together in a table. Okay. And Shobhargo and Irina make chocolate syrup out of it. Okay. And what they do is Shobhargo at first sallows the chocolate syrup, then put it out of the mouth, then the chocolate syrup comes down, then Irina has it, takes it in the mouth. So in this way they have 4 chocolates, because 2 chocolates they already had. Okay, and this was a syrup of 2 chocolates. Okay, so Shobhargo took the 2 chocolates. Okay, swallowed it little bit and then put the entire chocolate out of the mouth. So his 4 chocolate is accomplished because it was a syrup of 2 chocolates. And then Irina takes the 2 chocolates. Okay, so her also 4 chocolates are accomplished. So this is how they shared. Okay, I hope now this, if you understand this, let us understand in case of the most simplest molecule. Suppose, for example, oxygen molecule. In oxygen molecule also there is covalent bonding because there is sharing of electron. How I will tell you. First oxygen, I will write down oxygen like this. Okay. Then what I will do is, now you see whether it is giving or electron or taking of electron, it happens in the last shell. It doesn't happen in the first shell or the second shell or the fulfilled shell. Whatever shell it has, it happens in the last shell. See, whatever the number of shell it has, it happens in the last shell. Okay. For example here, giving of electron from the last shell. Taking of electron in the last shell. In the valence shell. The last shell is known as the valence shell where valence electrons are there. The last shell is known as the valence shell where valence electron is there. Okay, the last shell is known as the valence shell. Now, I will only draw as dots, okay, only the electrons of the last shell. Now, you know oxygen's atomic number is 8. So that means 2, 6. Only the last shell I will draw. Okay. How? Last shell I will draw means I will only draw the electrons of the last shell. 1, 2, 3, 4, 5, 6. Now you could question me here, sir, you could have given the dots like this. There are 6 electrons, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. In this way you could have given, or you could have given 1, 2, 3, 4, 5, 6. In this way you could have given. Why did you choose this method? 2 up, 2 side, 2 down. You could have given this in this side also. This also would be right. That you will understand eventually why I did like this, because I want to draw another oxygen here. Okay. Now here also, this is also an oxygen molecule. So last shell mein there are 6 electrons. So 1, 2, 3, 4, 5, 6. Now what will happen? Let them share these 2 electrons and let them share these 2 electrons too. Now start counting. Now these shared electrons are like chocolate syrup in the previous case. Now this electron belongs to this oxygen, this electron belongs to this oxygen, but this electron also belongs to this oxygen, this electron also belongs to this oxygen, because they have shared it. However, these electrons belong to this oxygen, this electron belongs to this oxygen, this electron belongs to this oxygen, this electron belongs to this oxygen only. But however, I just want to tell you that now if you count, what it should become at last shell, it should become 8 electrons, right or wrong? So 1, 2, 3, 4, 5, 6, 7, 8. See, fulfilled. 1, 2, 3, 4, 5, 6, 7, 8. Fulfilled. So oxygen double bonded to oxygen. Sir, why double bond? Why 2 covalent bonds? These are 2 covalent bonds. Because always remember, sharing of 2 electrons makes 1 covalent bond. Makes 1 covalent bond. Sharing of 2 electrons always make 1 covalent bond. Sharing of 2 electrons always make 1 covalent bond. Here 2 electrons are shared, so 2. I will give you more examples. Suppose, for example, in case of nitrogen molecule, oxygen molecule I have done. Now both the oxygen, this oxygen molecule is a non-metal, this oxygen also non-metal, so bonding between non-metal and non-metal only, and it is occurring by sharing. So in O2 molecule there is covalent bond. Let us do for H2 molecule, another very interesting. H, there is only 1 electron in the last shell, if you remember. Okay, the electronic configuration of H, there is only 1 electron in the last shell. You can check your copy, there is only 1 electron in the last shell. And there is another H, there is 1 electron in the last shell. So if this is the H atom, one proton, no neutron, and 1 electron in the last shell, and if it becomes 2 electron in the last shell, it will be fulfilled. So another hydrogen comes so close that its shell is like this, and let me draw this this hydrogen ka electron here and this hydrogen ka electron here. So it is being shared. See, now in this last shell we can say 2 electrons, in this last shell also you can say 2 electrons. So it is shared in a way. So in this way hydrogen bonds up with hydrogen. So hydrogen bonded with, single bonded with hydrogen. So that is the H2 molecule. There is one covalent bond. So in case of oxygen there is 2. This is double bond. We say call it double bond, double covalent bond or double bond. And in this case we call it single bond, single covalent bond or single bond. I hope that you understand this. Okay, let us do for case of nitrogen. Now look carefully. Nitrogen is N2, so that means 2N will be there. Okay, now how to do? Nitrogen is 7 atomic number, so electronic configuration is 2 5. So valence shell mein there is 5 electron. So how to arrange the 5 electrons, right? Now remember it requires 3 electrons. So definitely there will be sharing of 3 electrons, as because it requires 3 electrons. So in front you put 3. In the front you put 3. So 3 electrons and more 2. 1, 2, 3, 4, 5 electron, valence shell electron done. 1, 2, 3, 4, 5 electron, valence shell electron done. So it will share this electron, this 2 electron. It will share this 2 electron. It will share this 2 electron. Now count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen does triple bond with another nitrogen. So this is known as triple bond or triple covalent bond. So I hope that you understand that it has triple bond or triple covalent bond. Always remember another one more thing, that you, as you have seen in case of oxygen, I am doing again 1, 2, 3, 4, 5, 6. Now I hope that you understand that why I put 2 in front, because oxygen is 2, 6, it requires 2 electrons. So 2 here 2. So 1, 2, 3, 4, 5, 6. Now bonding here and bonding here. 1, 2, 3, 4, 5, 6. Now if we count totally 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. For both of them it is fulfilled. So oxygen double bonded to oxygen. Remember, these electrons which does not share but is in the last shell is known as the lone pair of electrons. Okay, that do not share but is present in the last shell is known as lone pair of electrons. So these are also lone pair of electrons. But in this case, which takes part in bonding, are known as bonded pair of electrons. They are known as bonded pair of electrons. Please remember that they are known as one. In this case, this nitrogen has one lone pair of electron, and these are bonded pair of electrons. There are 3 bonded pair of electrons, so there are 3 bonds. In hydrogen, there is only one bonded pair of electron and no lone pair. So I hope that you have understood the structure of O2, N2 and H2. Now moving ahead, let us try to understand the structure of CO2 or CH4 or NH3 or H2O. Okay, let us try the structure of this. Okay, now when you try to do the structure of this, always remember that in the compound, the element which is in less number is the central atom. Always remember. The element, this is the central atom. In case of CO2, C is the central atom. In case of NH3, N is the central atom. In case of H2O, O is the central atom. In case of CH4, C is the central atom. Means whichever is in less number. CH4 mein C is in less number, C is the central atom. CO2 mein C is the central atom. NH3 mein N is the central atom. H2O mein O is the central atom. Now what it does is, suppose if I show you CH4, C is the central atom, to put C like this. Now imagine in your mind that H requires only one electron. H has already one electron. So if it can be able to share one electron with carbon, then it will be fulfilled. 1, 2. So you arrange the electrons in C in such a way that 1, 2, 3, 4. Because C is what? C atomic number of carbon is 6. So that means 2, 4. So in the valence shell, how many electrons? 4 electrons. So 4 electrons will be arranged in 4 directions like this, and from the 4 directions H will come with its 1 electron, another H with its 1 electron, another H with its 1 electron, another H with its 1 electron, and it will bond up, share, and it will share, and it will share, and it will share. Okay, so it shares and makes CH single bond H, single bond H, single bond H, and in this type of bonding it makes it CH4. In this type of bonding it makes it what? CH4. I will do another in front of you, that is CH. Let me do H2O. H2O. O is the central atom. O written. So there will be 6 electrons in case of O, right, in the last shell, because it is 2, 6, and from 2 sides 2 H will come. So arrange the 6 in this way: 1, 2, 3, 4, 5, 6. From one side 1 H will come, from another side with its 1 electron 1 H will come, and it will share up like this, and it will share up like this. So what will happen? O bonded to H, O bonded to H, and there will be 2 electrons top and the 2 electrons at the bottom. So it forms H2O. I hope that you have understood covalent bonding. Here you see bonded pair of electrons. These are bonded pair of electrons, and these are the lone pair of electrons. In this case, there is no existence of lone pair of electrons. Now, I would urge you that to understand that this type of structure is known as electron dot representation. Electron dot representation. This type of structure is known as electron dot representation. Always remember, it is known as what? No, electron dot representation. Always remember. Okay, this is electron dot representation. 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 Okay, so these are electron dot representations. Sir, you have done electron dot representations, but in case of that means electrovalent bonding, there will be not electron dot representation. Obviously, there will be electron dot representation. I will show you electron dot representation of one of the electrovalent bond. Suppose, let me show you bonding of AlCl3. How to do electron dot representation? Just draw one Al, because there is one Al, and 3 electrons at the last, and then 3 Cl are there. 1, 2, and 3 Cl are there. So last shell of Cl, how many electrons are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. If you remember, it is 2, 8, 7. That's why. And 1, 2, 3, 4, 5, 6, 7. Now in this case, giving and taking of electrons will be there. So it will show in this arrow way. It will show in this arrow way. And you will show in this arrow way. What is actually happening is aluminium is losing 3 electrons, isn't it? Aluminium is actually losing 3 electrons, and chlorine needs to gain just 1 electron, but there will be 3 chlorines taking 3 electrons, isn't it? Okay, so if it takes 1 electron, it will become 8. If it takes 1 electron, it will become 8. If it takes, and it will also be satisfied. So in the next diagram, what you have to show is, this is one diagram. In the next diagram, you have to show is that aluminium plus 3 is combined with Cl 1, 2, 3, 4, 5, 6, 7, 8 minus 1, but how many in number? 3 in number. So at the beginning you put 3, so that gives you AlCl3. So that is the electron dot representation of what we can say AlCl3. Now for your homework, you will show me electron dot representation of covalent compounds of Cl2, N2, CO2, H2O, CH4 C2H6 NH3 N2 O2. Okay, Moshaddar. So that is one. And in case of covalent compounds, electrovalent compounds, your homeworks are MgCl2, all electron dot structure you will show. Electron dot structure. MgCl2 you will show. And actually this is not homework. I'll tell you when to do. Wait. MgCl2, Al2O3, NaCl, CaO, K2O, bus, and Na2O. Bus, do this much. Okay, and I'll be happy with your electron dot structure. And the last but not the least, difference between electrovalent bonding or electrovalent compound and covalent compound. Now I will mention, just I will not write, you will write down. First, electrovalent compound is formed by giving and taking of electron. Covalent compound is formed by sharing of electron. Electrovalent compound is formed between metal and non-metal. Covalent compound is formed between non-metal and non-metal. Electrovalent compound, as because there are charged particles in the electrovalent compound, they can conduct electricity. Covalent compound cannot conduct electricity. Okay, electrovalent compounds are generally solid, as because there is strong force of attraction between positive and negative charge. Covalent compounds are not generally solids but liquids and gases, as because there are not very strong force of attraction. And these are the four so these are the four basic differences. So that are the properties and basic difference. Oh, electrovalent compound has a high melting and boiling point. Why? Because there is strong force of attraction. And covalent compound has low melting and boiling point because of low force of attraction between the molecules. So I hope that you have listened to me. You will write down this. This is also your homework, part of the homework. And you will send it to me by tomorrow morning. You will send it to me by tomorrow morning. You have to do it by tomorrow morning. Thank you. So that is one part.